Hello everyone. So today we'll discuss the CSIR net previous year questions of the topic solid state chemistry. So this is a part 1. Similarly there will be part 2 and 3. In this part we'll cover the questions that came from the year 2013 to June 2025. Okay, starting with the first question. A A compound of M and X atoms has cubic unit cell. M atoms are at the corner we know 8 atoms and contribution is 1 by 8, plus at body center contribution is 1. X atoms are at the face center, total 6 faces, contribution half. The molecular, now you have to solve this. This is M1 plus 1 X3, so M2 X3. So the correct answer will be 4. Okay. Now the second question, the coordinates of an atom in a body centered cubic unit cell are. We know that in a body centered, so this is a cube. We know in a body centered the atoms are present at the corner as well as at the center. Okay, so the coordinates will be, see, total number of atoms present in a body centered cubic are 2, so 1 will consider it on origin 0 0 0. Okay, like this, if we consider region 0 0 0, right? So this, if we assume the length 1, so this, the coordinates of this point will be half, half and half. So the correct answer will be 2. Okay. Now moving to the third question. The interplanar distance of this plane in a cubic structure with lattice parameter of 4 Armstrong. We know that to calculate the interplanar distance, the formula is A h square plus k square plus l square. Okay, now A value is 4 Armstrong, so we'll put here 4. This is Miller index HKL, so this is 1 square 0 square 0 square, so the answer will be 4. Okay, 3 will be the correct answer. Now fourth, this is a theoretical question. When Frankel defects are created in a otherwise perfect ionic crystal, the density of the ionic crystal. See, in the Frankel defect, what happens, a cation will leave its original position and it will move to the interstitial sites. See, it have left some position and came to the other position, so density, overall density will remain same, right? So the correct answer is 3. Fifth is number of rotational symmetric axes for the triclinic crystal system is. Now we know that in a triclinic crystal system, A is not equal to B is not equal to C, and also the angle between the planes are not equal to, they are not equal, right? They are not equal. So this is a triclinic system. So in the triclinic system, we know that this is a most unsymmetrical system, so there is no symmetry axis present, so the answer will be 4, right? Next, the packing fraction and the number of atomic site per unit cell of FCC. We know that in FCC Z value is 4, that is the number of particles present per unit cell is 4, so this will be 4, and the packing fraction we know that is 74%. Okay, so the correct answer will be 4. For a simple cubic lattice, the angle between 201 plane and xy plane, you have to find the angle. We know that, we know the formula of angle, it's cos theta h1 h2 k1 k2 L1 L2 divided by under root of h1 k1 square L1 square multiply by h2 k2 and L2 square, right? Now this is h1, this is h1, okay, 0 is k1, this is L1. Now the question is xy planes, we have to calculate the Miller index of the xy plane. Now see, xy plane is that plane which is parallel to x and y axis and intersect the z axis. So its Miller index will be 0 0 1. Now you can easily find cos theta 0 0 into 0 1 into 1, this is root 5, this will be 1, so 1 upon root 5. So see, cos theta its value will come, see, very simple है ना, we know that under root 4 is 1 by 2 है ना, root 4 is 2, so root 5 is greater than root 4, so it will be 2 point something, like 2.24 or something है ना. So we know that cos theta values, we know if the theta is 0 degree, 30, 45, 60 and 90 है ना, values will be 1, here 0 because it decreases like this, 1 by 2, this is 1 by 2 under root 3 by 2, right? Now see, now this overall value decreases है ना. So we have seen that cos theta value, it decreases as we move from 0 degree to 90 degree, so the value will come over here है ना, so it will be between 60 to 90, so the answer will be greater than 60 degree. So these type of logic you have to use while solving the question. You don't have to remember every numerical values, logically you can solve the questions, okay? Now 8th question, in a cubic crystal the plane 1 0 0 is equally inclined to. In this also you have to utilize this formula, you have to find the angle between this and this, then you have to find angle between this and this, you have to see whether the angle is similar or not, okay? Now let's solve this one. 8th question, one, if we find the angle between this and 0 1 0 है ना, the angle will come 1 into 0 0, 0 into 1 0, this 0 divided by 1 1, so this is 0 है ना. Cos theta will come 0, theta will come 90 degree, right? Similarly if I find the angle between this and this one 0 1 1, these are the Miller indexes, ठीक है. So the cos theta value will be 1 into 0 0 0 and 0, similarly 1 1, this is also 0 90 degree, so in first only same angle, so the answer will be 1. Similarly you can find second, third, fourth, the angle will be different, so the correct answer will be 1, right? Now next question, in 9th question, each word in two-dimensional hexagonal close packed layer of circle is surrounded by. Now you should remember that in hexagonal close packing their layering is of AB type, right? While in FCC या CCP both are same, layering is of ABC type, right? So they are talking of two-dimensional, ठीक है, so this will be the layering. In the void of the first layer you have to put second, okay, right? So you have to tell how many circles are there. Let's consider for example I consider this है ना, so how many circles are surrounding this one? Now see there will be 1 this, 2 and 3, there will be no sorry, in this we have to find the void, coordination number of the void. Okay, so coordination number of the void is, this is a void, so only these 3 circles are present around this void. So this 3 circles. Okay, this is they are asking for void, so you have to consider the void, not the full circle. See, this void is surrounded by 3 circles. So in a hexagonal closed packing, each void is surrounded by 3 circles. Okay. Okay. Now, if atoms, ions in the crystal are taken to be hard sphere touching each other in a unit cell, then fraction of the volume occupied in a body centered cubic. See, in a body centered cubic, we know that fraction of volume, the packing fraction formula is, it's a number of atoms present in a BCC over into volume of each particle divided by the total volume. Okay. Now, if we consider total volume, okay, if A is the edge length, right, so the total volume of the cube will be A cube. In a body center 2, volume of each is 4/3 pi r cube A cube, right. Now we know that in a body centered, 4r is equal to under root 3a, so r will be under root 3/4a. So put here the value 2 into 4/3 pi a cube r cube. Okay, so this will be under root 3/4 a's cube. Now if we solve this, pi a cube under root 3 into 3, 4 into 4 into 4 a cube, this will cancel out, 3 3 4 4, so this will be under root 3/8 pi. So the correct answer will be 4. So actually the packing fraction is the volume which is actually occupied by the atoms over the total volume. Okay. Now if all the lattice points of FCC structure are occupied by uniform hard sphere that touches each other, then the fraction of volume occupied is. Now see, here also they are asking about packing fraction. Same formula will use. In FCC, the value of Z, that is number of particles present per unit cell, is 4 into volume is 4/3 pi r cube. This is the volume of each atom divided by the total volume. Here we'll consider 4r is equal to under root 2a relation. From here we'll find the value of r, which is 2/4a. Then on evaluating, we'll get packing fraction as under root 2/6 pi, which is 74%, है ना. So the correct answer will be 1, right. Then okay, now 12th question is, in a cubic crystal, the 1 1 1 and 2 2 2 reflections are observed, but 0 0 1 is not. The Brevis lattice is. See, we know that in the simple rule of this is, if this is simple cubic, है ना, any value of HKL is considered. For BCC, it's H plus K plus L should be even. For FCC, it is either HKL all odd or all even, but that should not be the mixture. Okay, so in this is all odd and all even, so the answer will be 2, right. Now the nearest neighbor distance in the crystal system of side of length a is this n. Now they have given the value of D, nearest neighbor distance. Okay, so you have to tell which is the crystal structure. We know that in FCC 4R is equal to 2A and D is equal to 2R, right? In BCC we know that 4R is equal to under root 3A and D is equal to 2R. Now you can evaluate 2R from here. You can see 2R will be under root 2 by 2A. Here 2R, which is equal to D, will be equal to under root 3 by 4A. On solving this, we'll get A under root 2. So this will be FCC. These are the very simple question. You can do it easily. Now this is of Miller index. Okay, now they have the Miller index of the plane as shown in the figure and parallel to C axis is. Now see, this is x axis they are referring as A and y axis they are referring as B. Okay, so you have to tell the figure which is drawn what are their Miller index. Very simple. See, if we consider this as origin, okay, the points are 0 0 0. Okay, so this is 1 2 and 3 and 4. So this is A intercept is 4. Similarly B intercept is 1 and 2. Okay, so it is parallel to C, it will meet C at infinity. So these are the intercept. To calculate the Miller index we have to do the reciprocal of the intercept. Okay, now just solve it. This will be, if I multiply 2 like this, so this will be 1 by 4, 2 by 4, 1 by infinity. So this will be 1, 2 and 0. Okay, you have to take the fraction 1, 2 and 0. Second will be the right answer. Okay, now next question is, this is an important question. Okay, because it came 2 times, 2021 and 2022. So in this question I'll explain you, but you have to open up your imagination, right? In this they have asked in CCP packing. So CCP packing is basically face centered. Okay, FCP, the number of lattice point per unit area in a plane is in the order. So they have given 3 planes. Okay, so firstly we have to evaluate 2 points you have to do in this question. Firstly you have to evaluate the area of the plane, and secondly you have to calculate the number of lattice points which are present in this area, right? Very easy question, we'll do it very nicely. Okay, so let's consider firstly 1 0 0, right? So in this, firstly you have to make a cube. You have to open up your imagination, right? Let's say this is x axis, this is y axis and this is z axis, right? So this is basically which plane? Now this is y is 0, z is 0, it cuts x axis, so it is yz plane. Okay, now yz plane, it means this is this one, right? Now you have to see, because it is cutting x axis parallel to y and z. Now in this plane this is an FCC, so 1 it will be present here at the center and then at the corner, right? Okay, now if I want to calculate the area, see this is a square, length is a. Okay, a square, area of this plane is a square. We are talking about 1 0 0 plane. Okay, now then we have to calculate number of lattice point present. See, there are total 5 atoms. This atom in the middle, it is not shared by anyone, so it's here z, here this will be 1. not shared by anyone, wholly it's all contribution. But the atoms which are at corner, it just contribute 1/4 to the plane, right? So 4 atoms, it will contribute 1/4, so 2. So number of lattice points which are present in this area is 2, right? Now you have to calculate per unit area, ठीक है? In A square, the number of lattice points present are 2. In per unit area, it will be present 2 by A square. I hope that is clear, right? Now we'll discuss the second 110. Okay, 110. Similarly, you have to draw a cube, basically an FCC crystal structure. X, this is Y, and this is Z, ठीक है? Now see, 1 मतलब here X intercept, Y intercept, ठीक है? So this is basically, you have to draw like this, X intercept, but it is not cutting Z, okay, only X and Y. Now and then this point, okay, so this will be your plane. See, this will be your plane, right? Now see, you have to see it very carefully. See, 4 atoms will be present like this on the plane, like in the previous example. Now firstly we'll calculate the area. Area is length into breadth, okay? If the length, this is A, right, breadth is this one, right? So this is basically a face diagonal. We know that face diagonal is under root 2a, so total area will be under root 2a square, right? Now we have calculated the area. Now main is to calculate number of lattice point present in this area. Now see, there will be these are the face center, है ना, cubic. So face center means there will be the atoms present at the center of the face. Now the atoms which are present at the corner will contribute 1/4, 4 into 1/4, but which are present at the surface, that is face center, will contribute half. Now in this plane there are only 2 face center atoms, so 2 into half, okay, so 1 plus 1, 2. So here the area per unit is 2 divided by under root 2 a square, or we can do under root 2 a square, ठीक है? We have calculated. Now the last one is 111 plane. In this also we'll draw 111, we'll draw a cube, ठीक है? This is x axis, this is y axis, and this is z axis. Now 111 मतलब 1 here, 1 here, 1 here, so this will be your plane, okay? Let me highlight this. So this will be your plane, right? Now see, this here atom, and here atom. Firstly we'll calculate the area. Now area, this is an equilateral triangle. We know the area of equilateral triangle is under root 3 by 4 a square, ठीक है? Now here a is this one length, this is a face diagonal, so a is under root 2a, so under root 3 by 4 under root 2a the square. Now when you will solve it, you will get under root 3 by 2 a square. This will be the area. Now we have to calculate the number of atoms which are present in this plane. Very easy. See, we know that this is a CCP, so here 2, 3, 4, 5 and 6. Okay, now in this we'll find that the atoms, 3 atoms, this one 1 2 3, which are present at the corner, since they are making an angle of 60 degree, they will contribute 1 by 6, right? And there are 3 face center atoms which are present in this. Okay, that you have to imagine, like in this plane there are these 3 atoms which are present and they will contribute half. Okay, now on solving this, 1 2 4 by 2, that is 2. Here you will get the area 2 by under root 3 by 2 a square, which is, when you will solve it, you will get 4 under root 3 a square. So on comparing this 3, you will get 111 is having highest per unit area, then is this 100, then is 110. So the correct answer will be 3. Now this question is somewhat like solving question, and you have to imagine how many atoms are present in a plane. That you will get when you will draw a proper diagram. If you're not getting like that, you can see it from the Google, a proper 3D image. From there you will get the idea. Okay, now is 16th question. The Miller index of the plane parallel to B axis and intersecting A and C axis. Now see, this is parallel to B axis, so B intercept will be infinity. Okay, now you have to find A and C. So if I find like this, for part A, see, C intercept is 2 and 1 2, A intercept is also 2, है ना, and B intercept is infinity. You have to inverse it and you will get 1 0 1. Okay, for the second part, see, for the second part what you will do, this one is line, this line is second one. Okay, now for this what we will do is, we'll consider this one. Okay, so here it is 0 0 0. Okay, this C intercept how much? 2 point. B intercept we know infinity because it is parallel to B axis. A intercept 1 2 3 4 point. 4 point. Just inverse it. So this will be 1 by 4, 1 by infinity, 2 by 4, है ना? So it will be 1 0 and 2. So the correct answer will be option number A, right? Then is 17th question. AXBY crystallize in FCC lattice. Now A occupying every corner, 8 corner, 1 corner's contribution 1 by A. B occupying the center of each face of the unit cell, 6 faces, half contribution. Correct stoichiometry is A1 B3, AB3. This was a very simple question. So 17th is 1, right? Okay, next is for the face centered cubic FCC packing of a monoatomic solid, the number of tetrahedral octahedral holes within the unit cell. We know that in a face centered, you have to remember number of atoms present per unit cell is 4, and it is having a very simple formula. The octahedral void will be equal to Z and the tetrahedral void will be equal to 2Z. So octahedral void will be 4 and it is 4 into 2 8. So tetrahedral 8 and octahedral 4. Okay, correct answer will be 1. Now this is a statement type question. So first is Z and S exhibit both cubic and hexagonal structure, which is true. sulfurite exhibit this ZnS structure, true. This is also a semiconductor, but the fourth statement, ZnS can be precipitated from aqueous acid solution of zinc salt by passing this is wrong. We cannot precipitate it, so the correct answer will be 1. Right. Now next is the option showing the correct structural type for this and this. Now you know that spinels, what are spinels? This is AB2O4 type, है and what are perovskite? These are basically ABX3 type, where AB are metal ion and X is somewhat halide. So this is spinel and this will be perovskite. So this is the correct answer. Okay. Now 21, the radius of cation is given, radius of anion is given, right? 170 ppm. The coordination number of cation and best possible geometry. You have to find the radius ratio in this. It is equal to radius of cation divided by anion, 74, this one. So it will come approximately like 0.435, right, when you will solve it. Now it is coming between 732. We know that if the radius ratio is between this, then the coordination number is 6 and the geometry is octahedral. So this will be the right answer, right? Then is 22nd question, very easy question. You are given with the density 2.7 gram per centimeter cube, mass you are given with 27 gram per mole, ठीक है. Edge length मतलब A you are given with 400 picometer. Now everything is in centimeter, will convert into centimeter, ठीक है. We'll multiply it with 10 raised to power minus 10. You have to find the crystal lattice. You know density formula, Z m Na A cube. You have to put the value of density. Z will evaluate this given. This is a Avogadro number, ठीक है. A we have. When you will solve this, okay, everything, you will get Z equal to 3.84, which is approximately equal to 4. We know that Z4 is for FCC. Now you have to remember, okay, Z is for BCC it is 2, for simple cubic it is 1. So for FCC only Z is equal to 4. I hope you learned the concepts as well as enjoyed solving the question. Now we'll move to the part 2 and we'll see the rest of the questions. Thank you.